Hi, this is Niklas. I'm the CTO and co-founder of Log10, and we want to talk about how you can scale reliability of LLM applications using a new tool that we've built. During this year, I think we all can agree that there's been like this kind of craze in the industry, and we've been rolling out a ton of intelligence features based on GPT, and we're now kind of finding ourselves in a now what moment. Because without knowing what good means in a generative setting, it's really hard and risky to evolve your applications, like changing your prompts, configurations, let alone considering going from one model provider to another to more advanced use cases like self-hosting or fine-tuning. We want to introduce a new tool today called llmeval that enables teams to ship reliable LLM products. It is a command line tool that you can run locally, and with these 4 lines of code, you should be good to go. The initialization creates a folder structure and best practices for storing prompts and tests. And then this is based on a super configurable system from Meta called Hydra. So you could basically extend it to your heart's desire, and the metrics that we have wired up are in Python, so they could be any logic, could be called out to all the LLMs, whatever you want. And after these evaluations have been run, you can generate some reports that basically give you like a brief overview of how the entire app and all the tests are looking, but still supports flexible test criteria, because like these models are very fuzzy. It's very hard to say with a guarantee that it's going to be one or the other, but it's fairly safe to say that the majority cases, or say 3 out of 5, should pass. And we're going to jump into command line and taking a look. We're just going to create a directory for today and go into this directory and create ourselves a virtual environment. From here, we're going to install llmeval. And initialize the folder structure. What we should be able to see here is a directory structure where we have our prompts. Let's say a simple case could be this, where we have this message template saying like, what is A plus B? Only return the answer without any explanation. So in this case, we know that we have to prompt engineer further in order to get an exact output. Because let's take a look at how the test looks like. In this case, we're taking like the actual output from the LLM and comparing it with the expected. And this is like a strict comparison. What we had taken the liberty to do is to strip any spaces that might come from the left. And that's because some models, in this case Claude, tends to prepend spaces. And so it's things like that that you have to watch out for. And then we have the metric, which could be any metric that you want to surface in the report. And then the result, which is then a pass or fail. And in this case, we want to add 4 and 5, and we expect it to be 9. And I'm just going to try to run this test here and try to revert some of the prompt engineering that we did earlier. So I'm going to remove only return the answer without any explanation. And the way you get started is llmeval run. But if you want to override anything, if you just do llmeval run, it runs everything. But if you do like prompts equals math, then it's only going to run the math example. If you do n tries 1, then it's just going to do 1 sample. By default, we do 5 samples. So we get like a better read on the stability of each test, but it might be too much for you. But you can override anything. You can find these default settings here in the llmeval YAML. But let's try to run this and see what happens. And so this ran across Claude, GPT-4, and GPT 3.5 once. So we can go in and generate a report and say, like, actually something failed. What was it that failed? So let's take a look at the output here. And in this case, because we removed our prompt engineering, GPT 3.5 starts being a bit chatty. It says like 4.5 equals 9. Claude does something similar. So it kind of writes out the equation. And now I'm going to try to revert and say, let's get this in. And we try to run one more time. Great. Now when we generate the report, it can say some tests failed, but the most recent test they ran passed. So when you do the report, it's going to generate like a summary. It's going to generate a report per run, but then also say overall, was there anything that failed out of these reports? If you want to go a bit more advanced, let's say you want to use tools. We have an example here where we are generating some Python code. And again, we had to add a number of different clauses to make sure that it only outputs Python. It tends to be very happy generating surrounding explanations. So in this case, we are going to see whether or not it returns an actual Python program that can be parsed. So let's try to run that. If you go in and take a look at this report, you can see that these tests actually end up passing our tool use. And to round up, we have model-based evaluation as well, where you can test using other models. And so in this case, say with grading, we can go in and define like a full set of criteria. Here we're evaluating mermaid diagrams, giving a score between 1 and 5, and the reason. And that is also supported in llmeval. One thing about the previous approach is that it takes quite an amount of work to set up these tests and gather your test cases. And one really compelling answer to evaluation has been model-based evaluation. And it's a setting where you have typically a larger model discriminate or kind of grade or be a judge over the output from another LLM. And that makes it so you can get more nuanced output like pass-fail or a grade from 1 to 5 or preferences between different options and its reasoning behind it. There's a number of pitfalls, unfortunately, around this approach, around biases towards the output from the model itself. If you're sweeping different models, they tend to prefer their own output. They're not very good at giving point scores, saying anything between 0 and 1, or larger scores between 0 and 100. But there are different ways where you can start increasing the accuracy of the kind of feedback that's being generated. And we've been working on this, where you basically start bridging between model-based and human feedback. So instead of removing the human completely from the feedback, you start taking in all feedback that might have been given prior and start modeling it and say, like, if you have all the feedback from John, then we create an auto John that will start generating feedback for review for any incoming completions. And so in this case here, we have 2 pieces of feedback that's been already given by a human. See here, it was overall just like a score of 5, or here it was like a bit more nuanced. But here we are kind of pending feedback. And if you click this, we have AI suggested an answer to this. And that's all I had today. If you want to get started on llmeval, we have our documentation at our usual documentation site. And you can find me at Niklas Quafford on X, or formerly known as Twitter, or shoot me an email at nick@log10.io. Thank you.